What if I told you that in just a few lines of code, you could write a microservice that's really easy to spin up with little to no configuration, and it would be instantly discoverable? You see, I have my name and the different instances that are running. Not only that, but it's instantly observable. You can get stats on each one of these instances. And I'm going to throw a bit of traffic on this. And you could see that we're also automatically load balancing between each of these services. As an added little bonus, you can also get the request and the reply schemas directly from these services just by talking to them. So you can do cool things like generate client code to talk to these services more directly with your language of choice. Now, you might think that we're using some crazy framework or a bunch of different tools and proxies between all these things, but we're really not. We're just using NATS and the new NATS Services API. Today, I'm going to show you how to use the NAT Services API so you can get all these really cool benefits. So let's jump straight in. Want to engage with the NATS community and talk with some of our maintainers? Well, you can go to the nats.io website and click on the community tab, and you can engage with us on social media. You can also join our Slack channel by clicking the Slack icon and join a community of over 5,000, almost 6,000 at this time, folks using NATS. And just as a quick reminder, if you really like this video and you want more content like this, please comment down below and hit that like button. Okay, so first things first, what is the NATS Service API? Well, to put it shortly, the NAT Service API is a set of conventions that is baked into a lot of our client libraries that makes building microservices really, really easy and brings all those benefits that I just went over. So today, we're going to be using the Go client library to write this in Go, but we also have support for this microservices API inside of the JavaScript and TypeScript clients. We have it in the Rust client, Java, and I'm sure a lot more, and a lot more to come as well. So for those of you who are new here, I'm going to give a quick explainer of what NATS is, because some of you guys might not know. NATS is a high-performance messaging system that's cloud-native and that allows you to build kind of these multi-patterned implementations and applications for distributed systems. And one of the things that we are starting to notice NATS users doing more and more is using NATS to build microservices. And so today we're going to dive in and we're going to build a microservice in Go, and we're going to go over all the really cool features of what it's like and how easy it is. But this can easily translate between a bunch of different languages. So I'm going to get straight into the code here. So today we're going to be building a sentiment analysis microservice that we can talk to, send some text to, and get kind of positive or negative feedback based off of our sentiment, based off of the words and sentences, et cetera, et cetera. So I already fired up a little Go project, and I did a little bit of work on the sentiment side just to kind of clean up some boilerplate so we can focus on the microservice. So let's open up main.go, and we just have a main func here. And before we actually start building our service, we need to fire up a NATS server. So again, NATS server is really easy to fire up, and this is what's going to be brokering all of our communication between our microservices, as well as allow us to start observing our microservices in real time. So you can download and fire up a NATS server very, very easily. And now back over to my code, we're going to start implementing this microservice. The first thing we need to do is connect to NATS. So we'll say NATS connection, an error. And we're going to use the NATS Go client library. We're going to call connect. And since we just fired up NATS locally for us, we're going to use the default connection URL that's built into the client. So we'll say nats.default URL right here. All right, and then we're going to handle that error. Now, since I don't want to keep doing log fatal lins here, I'm actually going to extract this out into a connect function, and this can return an error itself, and we could just start throwing that connect code over that way. Let's do that. Okay, so now we can return this error here, and we will call this connect function in the main, and we will, and then we will log.fatal if there's an error there. And we'll keep all of our functionality in the connect function, and we'll just say go runtime.go exit to just block until we receive a particular kill signal. Okay, so we've connected to to NATS, now we need to start using our NATS connection alongside of our microservice API. So let's return nil here just to clean this up. And the new API is bundled with our NATS Go client already. So we don't need to install a new package or anything like that. It's a sub package called micro. And we can call micro.addService. It will take a NATS connection, and then it will take some configuration for that particular service. So I'm going to fill out this micro.config struct. And you could see that we can give our microservice a name. We can have a default endpoint for it. Some microservices really only have one endpoint that you call. Others have multiple endpoints. And so we can also go over what it looks like to add multiple endpoints. You can give this a version and a description. And optionally, you can give us an API URL. Maybe you have an open API spec or another set of documentation that you want to point this to. We wanted to make services via this API really discoverable, so you could put them into large systems and people can kind of discover which services they can kind of use or what's available to them. So for now, we're going to call this sentiment to do our sentiment analysis. And for version, we're just going to go for 0.0.1. And then for our description, we're going to say analyzes sentiment for pieces of text. All right. Now we need to configure our endpoints, and our endpoint is really, it's a schema coupled with an actual handler. So if you're kind of used to working in Go and using like HTTP handlers, or in other languages working with like HTTP handling libraries, you're going to feel right at home here. The stats and done and error handler, these are kind of little extension points that you can add for your service, but we don't need them. We might go over the stats handler a little later in case you want to push custom stats, but we actually bring stats out of the box with this services API. And so let's go over here to this endpoint config to configure our first endpoint. So this sentiment microservice, we're going to listen on subject sentiment. I can call this whatever I want, or I could use wildcards, etc. if I need to, but we're just going to call this sentiment. And so this is the subject that we're going to listen on in NATS to be able to respond to requests. All right, now we want to configure our schema. Now I've already done a little bit of work here to create structs that we're going to be encoding and decoding into and from JSON. And so I'm going to pull up this little sentiment.go, and you can see we have a sentiment request that takes some text, and then we have a sentiment response, which embeds our sentiment analysis. And this is just coming from a library that I'm using for sentiment analysis. So you can kind of see we have language, words, sentences, and a score for this analysis. And all of this is going to be what's returned back from our request to this response. So those are the two kind of structures that we're using here. And what we want to do is, of course, we want to encode and decode into these structures just so we can have kind of a stable API. But we also want to expose these structures via JSON schema so it can interop with other languages pretty easily. So what I've done here is I'm using another kind of JSON schema reflector to look at these structs and turn them into actual JSON schema and return to us a request and response schema for our microservice, which is really, really neat. So I'm going to go ahead and call that. So I'm going to say our schema is going to call the schema function. And this also returns an error, so we need to handle that. And then we could simply just put our schema right here. There we go. Now we have JSON schema that we could share with the world in these microservices bundled automatically, which is really, really neat. Okay, so lastly, we need to have our handler, which is just a micro handler function. And this is just a special function that takes a micro request. In the Go client, this is an interface, but this is basically how you interact with your actual request. You can see the data that it's given you and the subject, and but then you also have some convenience functions like being able to easily throw errors, being able to easily respond via JSON, etc., etc. So we have our function right here that we can handle. And I said I already did a little bit of legwork on the sentiment front, so we can call a function to do sentiment analysis. But the first thing we need to do is we need to take the data that we get back from this request, and we need to encode it into our schema. So what we're going to do is we're going to call a JSON.unmarshal, and we're going to unmarshal our requests data that gets passed in, and we need to assign this to a value. So I'm going to say variable request. I'm going to call this R, and this will be our type of sentiment request, like this. And then we can pass this, easily just pass this in right here. And oh, here we go. Let's see. We'll name this one request, and we'll say request right here. There we go. And we need to handle this error. So we'll say error is this. And if we don't parse this correctly, we probably want to return like not a HTTP, because this isn't HTTP, this is NAT. We probably want to return a 400. So we can say request.error. We can give it an error code of like 400. And we can give it a description. Now, you know, I'm a little bit lazy right now, so I'm just going to return the error outright. But if you're building, you know, actual microservices, you might want to have, you know, specific error codes that you're handling here. I can also optionally pass back a payload if I wanted to. Maybe I want to encode this error into JSON or something like that. For now, I think I'm okay just having the error be embedded as a header. So I'm going to just hit no, right, like that. So if we pass it malformed data, we'll get an error back from the client, which is great. Okay, now that we've successfully parsed our request, let's actually go ahead and make our call to the sentiment analysis. So I'm going to call analyze sentiment, and I'm going to pass in that request that we got. And now I need to pass in a model that is of type sentiment.models. So what I'm going to do is I'm going to go up here, and I'm going to say sentiment.restore to bring in that model. And I believe that also returns an error. So let's put in an error, and we will also handle that error like this. Okay. So now we have our sentiment model, we have our request, and we can get back, whoops, let's make this a pointer, and we can now get back our response, which is a sentiment response here. So we can simply say to our micro request, we can say respond in JSON, which just takes an interface, which is great. And we can also add headers to it if we wanted to. There's all kinds of fun stuff that you can do. But for now, I'm just going to respond like this. Add a return and our error, and that all looks good. This is a very simple kind of handler. Again, if you're familiar with HTTP, this is going to look very, very similar. But the cool thing about this is we've kind of self-documented this service, and we know a bit enough about this service, and we can share that with people who want to know about what this service is, what it does, and maybe even how it's performing. And so this is, I believe, everything we need to run this service at this time. Let's go test this out. So I'm going to say go run. Oh, before I do that, let's actually just put some confirmation text here. So I'm going to say log.println, and I'm going to say listening on sentiment. And then we'll also include the connection, let's see, maybe the URL or the address, connected address. There we go. All right, so when we fire this up, if everything goes hunky-dory, we should be listening on for a sentiment subject on the particular NAT server. So let's go ahead and try that out. Go run main.go, or go run this. Let's try it out. Cool. So we're listening on sentiment for 127.0.0.1.4222, which is our default NAT server. If I click over here to the Discovery tab, all this is doing is it's running the NAT CLI to list out the microservices. So this will list out all of our microservices, not just the sentiment. And I only have one instance of this running, but you could see that I have a sentiment service, which is really cool, analyzing sentiment for pieces of text, just like we said. If we go over to the stats tab, we can say NATS micro stats sentiment, and that's going to give us different statistics for that particular instance of our sentiment service. Now, I'm going to close this out real quick and kind of show you what's going on under the hood here. So we're going to type trace. if you use NAT CLI, if you use Trace, it's going to tell you exactly what NAT CLI is doing to talk back and forth to the NAT server, which is really cool for debugging and discovery. So I'm going to hit Trace here, and it drew out this table for me, which is great, but it also kind of shows me how this whole thing is working. It's sending a request to this, what we call a control channel around services. So $serve stats sentiment. And what that's returning back is it's returning back stats about my particular service. Now, what's really, really cool here is this is a perfect example of end-to-end communication. Now, I only have one of these sentiment services running, but I could easily go ahead and run another one of these, run this stats function again, and you see I actually get 2 responses back, which is why we have 2 rows in the table. And this is a perfect example of somebody being able to use NATs to send out one signal and to get multiple responses back from each of these microservices. So these services, they aren't necessarily registering themselves with some stateful service discovery engine or anything like that. When we query this is actually going out to the services themselves, and the services are talking back to us, which is really, really neat. And you can do a lot of really cool stuff with that. You can see that we're showing some things in the table, but there's also other information inside of these stats. And you can also add custom statistics here as well. So if you're worried that this might not be fully fleshed out, or you want even more statistics, it's very, very easy with that stats handler that we looked at a little while ago to add custom stats and metrics here for your monitoring. And so that's just kind of one example of like, okay, we have service discovery, we have these kind of stats here. I'm going to bring this back up. And like I said, we also have this idea of, let's just put down 10. So I'll show you how this microservice actually works. Cool. So we sent it a bunch of sentiment. We sent 10 requests, and they got load balanced between the two, 5 and 5, which is great. And you could see the responses that we got back. So which language it is, how many words are coming back, what are the scores for each of these words. And it's kind of aligning. Super is getting a score of positive. Awesome is getting a score of positive. So very, very cool overall. Now, I can just parse this JSON all I want and do whatever I want with it, but it's not necessarily binding to maybe the types in my type system or working with my language in the way that it needs to be. And that's where the schema comes in. So we went ahead and we encoded a JSON schema from our Go types and put those into the schema. So we can do some cool things like call this schema control signal over here. I'm just going to quickly do that. So we can say, give me all of the schema for sentiment. And what that's going to do is going to return some JSON to us. So I'll JQ just to make this a little bit better. So you can see that we get the name sentiment back, the ID of who responded, which, this could be either one of these instances, whoever kind of picks it up first. We get our version, an API URL if we have it, but we didn't supply one. And then we get our endpoints. So since we only have one endpoint, we just have our default endpoint and we have the subject that it's on. So we can infer a lot of information here. And then we have these schemas. And so the cool part is you don't need to use JSON schema. You can actually put like protobuf in here. This is all just a string. So as long as you can kind of eventually encode it to a string, maybe base 64 it or something, you could really use whatever kind of schema that you want, which I think is really, really cool. And that way you can build tooling that can look at these schemas and decide what to do with them. So, what I've done here is obviously I'm looking at something like the response, pulling it out of the response I get back for the schema query. And I can do really neat things like, this is kind of my roundabout way of doing it, but I'm using Q to encode those values into QLang, and I'm pulling them back out into Go types. But you can use this to generate JavaScript. You can use it to generate Ruby, Rust, whatever you want to use. But this is, again, just kind of an example of like, you get a lot of really cool things out of the box just by using NATs and using some of these conventions around these control signals that we have. So that's kind of a overall high level view. This is going to be a shorter video just because this is really easy to pull off. And I recommend everybody kind of take take a shot at working with this in your language of choice. It's a really, really neat way, I think, to build out microservices, really novel way. And like I said, we built this out in just a few minutes. I mean, the bulk of the code is really just right here, this little micro add service statement here. It's really, really fun to build these. So highly recommend you jump in, go play with the services API. I guarantee you'll have a lot of fun doing it. All right, until next time.